Alright guys, so we're back with our Pontiac here. When we left off last time, we didn't have the timing set, and I ordered it. It is a double roller set from Cloy's. Now, one thing you got to watch out for here on some of these timing sets, if you'll notice there's more than one keyway on this crank gear. This is to advance and retard the cam timing. Advanced timing, if you move this to a different keyway, is going to move the power band of the engine. It's going to actually give you more low-end torque and less top-end RPM. And then if you go to the retarded position or the late position keyway, which is denoted with an R, it's going to give you more low-end torque, and it's going to cause the top-end power to drop off. The other option is the keyway that says 0 on it, which is straight up timing, which is what you want, especially when you have a performance type cam. The manufacturers, when they design these aftermarket camshafts, especially these bigger roller cams, they give you a power band in which the camshaft is going to operate best, and they grind the advance and retard into the cam already, and they recommend that you just set it up straight up on 0, just normal timing, and that's the way we're going to do it. And of course we have to degree this cam once we get it in there. So now the timing set for the Pontiac is actually real simple. The crank gear is not pressed on these engines. It is, if we put this gear on here, and you want to make sure that, you know, your 0 mark, the 0 or the straight up mark is lined up with your key. So we've got our key here, and you'll notice that on the crank gear, it just slides real nice onto the crank. It's not pressed on. The cam gear, the camshaft has a Woodruff key up here, and the cam gear is key. It has a key, and of course it has a timing mark on it as well. It's right there. I might mark that so we can see that a little better. But this whole set just slides on there. But what you've got to do is you've got to, when you set these up, you want these dot to dot. So you want the mark on your cam gear, which is right here. So I went ahead and marked that with a red marker so you can see it. You want those marks to be dot to dot, or you want this mark on this gear at 12 o'clock and you want this one at 6 o'clock. Now in some engines that puts the engine into overlap and you have to go one more crank revolution to get to TDC compression. On some of them, when they're dot to dot, they're on TDC compression. It doesn't really matter. As long as they're dot to dot, the engine is going to be timed. So the most effective way that I have found to do this is go ahead and put your gears on without the chain, and then we can move, you know, we can move the cam and we can move the crank and line those up. Okay, so I'm going to move my camshaft to where I eyeball it and it looks like it's at 12, and I'm going to do the same thing with my crankshaft here. Now to turn your crank, use the bolt. Don't put pliers or vice grips or anything on this key. Just get the bolt. Now I'm off a little bit here. I'm really not dot to dot. And rather than eyeball it, the best way I've found is to take a straight edge and put it right down the center of that crankshaft and that bolt, just like so. Now that crank mark, that's actually really close to being 6 and 12. You're not going to get any closer than that. It's basically 6 and 12. So I'm happy with that. Of course, we're going to degree the cam and make sure everything that is kosher once we get this on. Alright, so then go ahead and put your chain on there like this, guys, and line those marks up dot to dot. And then you just slide these two gears on. They have to be slid on together. It's a bit of a tight fit here, but it'll go on. and it is a snug fit. But once you get the cam gear started, then you can just very gently kind of push each one of those back, and they'll go on there. You may, if you have to tap this a little bit, that's okay. I'm going to take a soft hammer and I'm just going to gently tap. Notice I'm not using a steel hammer and I'm not beating the heck out of it. Just push these on evenly. And if you line them up right, they'll go right on there. We're lined up with our keyway there. And you want to go all the way back. All the way back up against the crank and then up against the cam here. And then of course we're going to have to get our bolts in it. Now once again, I'm going to take my straight edge and I'm going to go right in the middle of that and make sure that I'm lined up. Now if you'll notice, this mark is over here a little bit, but that's okay, because that just means that the crank needs to be turned just a little bit. But if you've got these really close dot to dot here, you're on the right chain link. If you were off a link on the chain, you would be a whole tooth off. I mean, this mark could be way over here, or this mark could be way over here where this tooth is. If they're not exactly lined up, but they're really close, that just means that the crank is not exactly at top dead center right here, or straight up, and it just needs to move a tiny bit. So we just need to take and move that crank just a little bit to where those marks pretty much line up. If we go back on here, you can see we're there. We're really dang close. Those marks are dead center dot to dot. So that's how you time it. Now we need to put our fuel pump eccentric and our cam gear hold down on here. I don't know if this customer is actually going to use a mechanical fuel pump. I'll be honest with you, I hope he's not, because I'm a big fan of electric pumps, but that's just me. Mechanical pumps are a parasitic draw, and you got to crank the engine to get fuel pressure. I don't really like that. I like full fuel pressure before I ever touch that key or engage the starter anyway. So your fuel pump eccentric has this little tab on it. This is the factory setup, and also they have partially drilled out a hole. That is what kind of locates that eccentric. So that piece of that tab that's sticking out goes right in that hole like that, and that's the inner piece. So you just put these together, and this actually is a two-piece, so the outer and the inner piece slide in relationship to one another, which reduces a lot of friction. And then of course you have your bolt and your washer. This is not the original bolt. We replaced it with a grade 8 bolt. There's nothing special about this bolt as far as its design. It's just a fine threaded grade 8 bolt. And I always put a little Loctite on there. It's not necessary. You could just torque the bolt, but you know me. I want everything overdone as far as putting this thing together. I don't want it coming apart. So then we just go ahead and get your bolt started in there and torque it to spec. Now the torque on this bolt is 45 foot-pounds. You would think that the torque would be more on that, because that is a big hefty bolt, but I mean, who am I to argue with the Pontiac engineers? John DeLorean would be arguing with me right now if I told him it should be more, and he'd give me all kinds of deep engineering philosophy why. So we're going to stick with what the engineers say. So you want to run that down, torque that thing to spec. 45, like I said, is not all that much. That's it. It's torqued. Make sure that this outer piece turns. And that is the installation of your timing chain. Now, we got our initial timing dot to dot here. Now, of course, in order to do this correctly, especially on a high-end build like this one, we definitely want to degree this camshaft. So since I'm going to degree the cam, and I know I have other cam degree videos, I've got a bunch of them, but I figured we run through it on the Pontiac as well. Now Pontiac has one strange feature that is actually kind of weird, and that is the way that the cylinders are numbered. Actually, the way that they're numbered is not weird, but the configuration of the cylinders. So you've heard this said many times by me on a lot of different engines, and that is the way you find the number one cylinder on an engine is you find the lead cylinder here. Okay, so if you look at the lead cylinder here, if we look at these cylinders, it's obvious that this cylinder over here, if you look at this set of lifters here, these are a lot further toward the front. This is actually the lead cylinder on the engine right up here, and then of course this one is behind it over here, and you can see where the lifters are. Now normally the lead cylinder on the engine, which is this one, is going to be number one. Well, on the Pontiac, that is not the case. The cylinder on the left bank, which is over here, and it's actually not the lead cylinder, it's further behind, is actually number one on the Pontiac. So it goes 1, 3, 5, 7, and then 2, 4, 6, 8, just like any other GM engine. But that's a unique feature that these have. So when we degree the cam, we want to degree number one. So we're not going to be using the lead cylinder to degree. We're going to be using the one that's further behind. So that's another thing you have to keep in mind. And also, one thing that's of note is the distributor rotation on the Pontiac is counterclockwise. The engine turns clockwise, but the distributor, because of the side that it comes into the cam, is a counterclockwise rotation. So there's a few little things like that that you have to be aware of when you're doing one of these. All right, you guys, so the next step is, if you take a look at this, you can see that we've got the degree wheel on, we got our chain on in there. In order to dial the timing in, and I've done cam degree videos before, what we've got is we've got a degree wheel bolted to the crank. This degree wheel is a little beat up, but I've had it for 20 years. I've built a lot of motors with this thing. Old faithful here. We also need some type of a pointer on the engine. I used to use a piece of wire. And we have this dial indicator for the lifter. This, you can buy this at Summit or Powerhouse, and make sure if you're using a roller cam like we are that you get the rounded piece. They also have a square tool that goes in here, but you want to put the round one in and snug it up. And we're going to get onto our lifter right there. But before we do that, we have to do something called finding true top dead center. So this pointer that I've set up here, I mean, I can put it anywhere I want. Right here on the wheel, if you look, it says 0 or top dead center. Now when we say top dead center, we have to find exactly true top dead center. As that rod moves in there, the rod can be on one side or the other of top dead center, and the piston has a little bit of dwell there. So we have to zero that in and make sure that the rod is exactly straight up and down on that piston, and we are a true TDC. Now another thing that's interesting here, we've got our dial indicator. This is a bridge gauge, and we've got our dial indicator. Now I zeroed this indicator out on a flat surface plate, and if you take a look at this, 0 right up here is exactly flat with the surface. I've got this piston up at its highest point of travel, and you can see that we're sitting right at 8 thousandths below the deck. So we have 8 thousandths deck clearance. That's really good for this motor. We want to be as close to that deck as we can. So we're down in about 8 thousandths. If I rotate this engine one way or the other, you'll see that going down this way is getting bigger. So that piston is going down right now. I'm going to come back the other way and come back up to the highest point of travel. So I'm coming back up now. I get about right there, and it reverses. So right there is actually the highest point of travel on our piston. Our 0 is our deck here. So I'm about 8 thousandths below the deck. So my deck clearance is about 8 thousandths on this engine. I've gone through and I already checked all of the rest of them, and they were all about 8 to 10 thousandths. So we're looking really good on this engine as far as deck clearance goes. That's right where we want to be. All right, so now I've got this guy at approximate top dead center, the highest point of travel on the indicator. Now I need to dial this in. So what I'm going to do is I'm going to set this thing. I'm going to go ahead and fine tune my needle here. And once you set this, you want to make sure that you don't move it. I'm going to bend this so this needle here needs to be right at top dead center. Now what I did is I put a little red paint on that thing so you can see it. So we're going to be right here. We're going to be right at 0. So you got to get that right on the money. Okay, so right now if you look dead on that, I'm right on the money on 0. And I'm at the highest point of travel here. Some people would say that that's good enough. It's not good enough as far as I'm concerned. So what I'm going to do is I'm going to rotate the engine backwards now, and I'm going to come down off of that 50 thousandths. But before I do that, I know what my deck clearance is. I'm not worried about it now. I'm just going to go ahead and zero that out. That's my approximate TDC there. I'm going to zero that out at the highest point of travel. What I want to do is I'm going to back this off. I'm going to go counterclockwise, and I'm going to watch my indicator, and I'm going to let the piston fall down 50 thousandths into the bore. So I'm going counterclockwise. So if I watch my needle, there's 20, 30, 40. Now when I go backwards, I'm going to go past 50, which that's 50 right there. And then I'm going to come right back to it in case there's any slop in the chain. We know there's not slop in this chain because it's brand new. So, and it's a heat treated pre-stretched double roller, so it's a Chloe's unit. We know it's good, but it's just a habit, just good habit. So go past it and go right back to 50 thousandths on your indicator. Now at that point, we want to read the wheel. So what I've done is I've pulled the piston down in the bore 50 thousandths, and right now I was at 0, and you can see I've gone exactly 10 degrees. Okay, so we want to make a mental note of that, or you know, we can even put a little mark there and say, hey, we're at 10 degrees. Okay, now we're going to go clockwise, which is going to push the piston back up to top dead center, right? So we're going to go back to where we came from, all the way back up to 0. There's our 0. Now we're going to continue, and we're going to go the other side of top dead center. So I'm going to go clockwise now, and I'm going to go right down to 50, and I'm going to stop. Okay, so I'm going to go right to 50 and stop. Now, if you take a look at this, and this is why we do this, we were at 10 degrees down over on this side. Now that we've come up to this side, we're at 12 degrees. So what that tells me is we are off by 1 degree. If you don't establish true top dead center, and the way that you fix this is, well, I need more degrees on the other side down here. I need more degrees on the other side, and I need less here. So since I'm at 12, I'm just going to pull the needle over to 11, right? I'm going to put it right at 11, and what that's going to do is that's going to take 1 degree away from here, and it's going to add 1 degree to the other side. So literally, you guys, what we are doing is we are fine-tuning this pointer to make sure that when it is on 0, I am exactly true TDC over here. And you know, we could have just found approximate TDC. We would have been within 1 degree. But to fine-tune this, you really gotta, especially on a performance cam, you really gotta do this. So now we're gonna go back and we're gonna do that again. So we're gonna go back up to TDC, which is my 0 right there. Now I'm gonna go backwards, and I'm going back counterclockwise. My piston's going down. You can see it's dropping down, and I'm gonna go past 50 and then right back to it, right there. And you can see, if you look at that, I have got 11 degrees. I had 10 before, now I have 11. So now I'm going to go clockwise back up to top dead center, and we're just going to go to 50 on the other side and make sure that we are the same on both sides. So if I go to 50 right there, I've got 11 degrees. So now I have 11 degrees on this side and 11 degrees on this side. So I know that what I know now is that when my pointer is on 0 TDC, I am at exactly true top dead center on my piston. That is the first step. Now that I've got my pointer set, I can go ahead and degree the cam because I know that my pointer is matching true TDC on my piston. Once you get true TDC established, you do not need this indicator anymore, right? You can take that off. You can leave it on there. We're just going to take it off because we don't really need it. All right, so now that we've gotten to this point, your next step is you want to take a real good look at your cam card. The cam card is the specs that came with your camshaft when you purchased it. This is a Howard's hydraulic roller. And so we want to look at a few things. The first thing we want to look at when we degree this cam, and what tells us whether or not our timing is advanced or retarded, is intake lobe center line. Because intake lobe center line, it looks at where the center of the lobe is compared to top dead center. And that will tell us whether or not we're timed. So if we look at this cam card, we've got an intake lobe center line of 103, which is pretty tight, but for what we're doing here, I really personally don't like wide lobe separation cams. The tight lobe separation cams have a peakier torque curve, and they actually carry the horsepower to a higher RPM range. So we're going to go ahead and we're going to look at 103 for our spec, and we're going to degree it. So the way that we do that is we want to make sure that our bore gauge on our lifter bore gauge is on the number 1 lifter. Now keep in mind, on the Pontiac, the second lifter back, not the front one, but the second lifter back is your intake on your cylinder head. The front valve on the head is your exhaust lobe. So this is going to be our intake lobe right here. So what we're going to do is we're going to get on the base circle of that lobe, and then we're going to zero our indicator. We're going to rotate this lobe until we get down. So you can see we're up. The nice thing about the Pontiac is you can see the lobes in there. We got an open area there. So right now I'm coming up on the top of my lobe, right? So what I want to do is I want to go to maximum lobe lift. So max lobe lift here is going to be the highest point of travel. Okay, so we're coming up. Okay, so we're going down the other side. We want to back up a little bit. So you just want to find your maximum lift point, which is right there. So right now, if you take a look at this, my camshaft, I am on the top of the lobe, or the max lobe lift point. Now when you get to that point, we want to zero our indicator. So you want to bring this around to 0. So now right now we are at the highest point of travel, or the center line of the lobe lift. Now that we've zeroed our indicator, in order to get intake lobe center line, we're going to do basically the same procedure that we did when we did true top dead center on our piston over here, except we're not on the piston now, we are on the tip of the lobe, or max lobe lift. So what I'm going to do is I'm going to come down backwards down past 50, right? So you can see our pointer up here. So I'm going to come backwards, and I'm going to watch my indicator, and I'm going to go down to 50 thousandths. Now since I'm going counterclockwise, I'm going to go past 50 and right back to it, just in case there's any slop in the chain, which again we know there's not on this engine, but it's just habit. And we're going to go right to 50. Now at that point, you guys, you're going to read your wheel. Now it's important that you are able to distinguish the difference on the numbers on this wheel. If you look at these numbers and the wheel down here, it even tells you white numbers and black numbers. It gives you an indication of what they're for. So what we have here is our white numbers are for checking intake lobe center line, or lobe center line, which is right what we're checking. The black numbers are going to be for duration when we do the duration. So right now we're doing center line. We came down off of our lobe 50 thousandths and we want to read our wheel. So right now I am reading exactly 57 degrees. Okay, so now that number, you just want to make a note of it. We're going to just go ahead and write it right here. So we got 57 degrees for our first number. Now what I'm going to do is I'm going to go clockwise back up to the top of the lobe travel, and you guessed it, I'm going to go down 50 thousandths on the other side of the lobe, right? So if we watch our indicator up here, I'm going clockwise, so I'm going back up to the center of the lobe, the highest point of travel, and I'm going to keep going, and I'm going to go clockwise, and I'm going to go down the other side. So there it reversed. I'm going down the other side of the lobe now, and I'm going to go right to 50 this time and stop. Okay, right to 50 and stop. And now, of course, we are going to read our degree wheel. And what we have is we have 150. So we have 150, and you remember on the other side we had 57. Now what you need to do is you need to take those two numbers and we need to add them together. So we got 150 plus 57 is 207. Now remember, our cam card says we're supposed to be 103. Well, what you have to do with these, because we are checking camshaft degrees and the degree wheel is bolted to the cam, remember the cam turns half the speed of the crank. So we have to divide that number by 2 to get our actual intake lobe center line. So divided by 2 is 103.5. So we are within a half a degree of where we should be. You're actually within a half a degree is considered dead on when you're degreeing a cam. So we are definitely timed correctly. We're happy with that. So 103 is what we got. And if we look at our cam card right there, and we look at our intake lobe center line, it says 103. So we've matched that. Whoops, I exited out of it. Now we know that our engine is timed correctly. It's set up. Now on a lot of builds, all we do is check intake lobe center line. We're going to go ahead and do duration on this as well, just because we can. So if we look at our duration, and we want to check duration at 50 thousandths. And what that means is I come off the base circle 50 thousandths and then I start doing my math here. The duration at 50 on this cam is 242, 250. That's a fairly radical cam, right? So 242, 250 at 50. And I'll explain to you what at 50 means here. So here's what we need to do. To check duration on this camshaft, we have a number. Now we're on our intake lobe, so we're just going to go ahead and use that. What duration is, you guys, is basically how many degrees does this crankshaft rotate while the valve is open, from a specific opening point to a specific closing point. Well, our specific opening point in this situation is 50 thousandths after the valve opens and 50 thousandths before it closes. How many degrees did the crankshaft rotate? We're going to take a look at that. So what we need to do is we need to get on the base circle of the cam. The base circle is the starting point for duration. Okay, so we're up on the lobe, we're going down now. We're going all the way down, going clockwise. Okay, Now, you can see that I am turning the crankshaft, but the dial indicator is not moving. If I'm turning the crank and the dial's not moving, that means that I'm on the base circle. And if I look down in here, I can see I'm on the base circle of the cam. So once you get on the base circle, you're just going to zero out your indicator. Base circle is starting point. So what we want to do to get our duration is we're doing duration at 50. That's what our card says. If you look right here, it says that my degrees of duration at 50 thousandths on the intake right there is 242. So we're on the intake. So from 50 to 50, we should have 240 degrees of duration. And this is just verifying that we have the right cam, basically. So now that I'm on the base circle, what I need to do is I need to come off of the base circle 50 thousandths. I need to open the valve 50 thousandths, and that's when I start reading my wheel. So I'm going to go clockwise. Here we go. We're waiting for that valve to open, and you'll see when the valve starts to open, or the lifter starts to push that indicator up, that means the valve is opening. It's pushing the push rod up, opening the valve. All right, so we're going to keep going till we get to that point. Okay. And the wheel will tell you, right here you can see it says intake valve open. So the intake valve is going to open in this area. It varies on some cams. Some cams will open early, some it'll be way over here. Just depends on the cam and how it's designed. Generally, if you have tighter lobe separation, it opens early. A wide lobe sep, we usually open back here, but you can see the cam's already moving, right? So intake open before top dead center. Here we go. So there it goes. Now we're going to come up 50 thousandths because we're checking duration at 50. So we're going to go to 50 thousandths. So what I have done is I have that lifter, I've rotated the engine until the lifter came up off of the base circle 50 thousandths, which means the valve is open 50 thousandths now. That is where we are going to get our first number. So if we look at our wheel now and we read it, here's TDC, we literally just need to read and we need to mark where we're at. So right now, our valve at 50 thousandths, right, before top dead center, is reading 10, 11, 12, 13, 14. So right there is our opening. So that's 14 degrees before top dead center. And that is 50 thousandths off of the base circle. Okay, so we've marked that. We know where we're at. Now what we're going to do is we're going to continue all the way up to the top of the lobe travel. We come off the base circle 50. We're going to continue all the way up to the top of the lobe travel, and we're going to go all the way down, and we're going to stop at 50 thousandths before the valve closes. So we're going to go all the way up. Now at the same time you're doing this, we can check our lift and make sure our lift is what it's supposed to be, because lift is how far off the base circle I come. So I'm at 50. Okay, there's 100, 150, 200, 250, 300, okay, right there. I have stopped and it's getting ready to go back down, and it says I have 348 thousandths of lobe lift. Let's check our card, right? So I'm on the very top of the lobe right now, basically back where we were when we did center line. So if I look at our gross cam lift on the intake, it says 350. Right? Well, we're within 2 thousandths. There's variations here. I mean, this thing varies a little bit. We're there. If you're within a few thousandths of your lift, you're good to go, right? So that does tell me that this is the correct cam. So we have 350 thousandths, 348 to 350 thousandths of lift. We have to keep going though, you guys, because we need to go all the way down until we get to 50 before the valve closes. So there's 50, we're going back down. So this is 200. This is 100. So now when I come around to 0, the valve is going to be closed, but if I keep going all the way to 0 here, I'm going to close the valve, or I'm going to come off the lobe and be on the base circle. But we want to stop, guess what, at 50 thousandths before the valve closes, right? Which is where we are right there. Now we're going to go back to our wheel, and remember, for duration, we're reading the black numbers. So we're going to take and we're going to look at where we're at. Right here, we are we have 44. We have 44 degrees. Now, you got to kind of think about what's happening with this wheel and count your rotations here. I want to show you what we got here. I'm going to back this up so we can see the whole wheel here. So now what we've done is we rotated clockwise, so that means that our duration, right, is going this way. So right here, this is bottom dead center. So from bottom dead center to here, right, we have 44 degrees. This is from here to here is 40, and remember our travel is this way. So we have 44 degrees. We've already got that written there. Now, from bottom dead center to top dead center, and remember our travel went this way, we know that from bottom dead center to top dead center is 180 degrees. And if you didn't know that, now you do. A half a turn is 180 degrees of rotation, okay? But we went past top dead center. We opened at 14 degrees before top dead center, okay? So we need to add that 14 degrees in because that's part of our travel. So we're going to go 14 degrees here. Now, if we add these together, if we did this right, that should equal what our cam lift is. I'm taking a chance here because I haven't added these up yet. I haven't done it in my head. I'm going to do it live right here for you. Okay, so we're going to go to our calculator and we're going to say, well, we got 180. We got 180 degrees of travel here from bottom to top. And we got to add 14 and 44. Plus 14 plus 44. We got 238. The cam card says 242. Yeah, so that's actually not uncommon for most camshafts to see a little bit of variation in the duration. A few degrees plus or minus is not going to make any difference in the way this thing runs. So, and I actually off camera did this again, and again we got 238, right? The cam card says 242. Well, that's a difference of, I don't know, 4 degrees, which is that much travel right there. And again, there can be variations in the chain, there can be variations in the indicator, but I did it twice and I duplicated it. When you buy a performance cam, if you're within a few degrees of what the card says, you know, some people make a big deal about that. Don't worry about it. I mean, I've seen all kinds of high-end race cams and that were off by a few degrees based on what the card said. You're in the ballpark of where you need to be. The opening and closing, if you look at the card, it says it opens, intake open at 18 degrees, right? Well, we opened at 14 degrees at 50. So yeah, I mean, there's a few degrees difference there, but I would say you're there. I'm very confident. I've run into this with a lot of different camshafts, and I've had absolutely zero performance problems with them. They performed exactly like the manufacturer said, and so yeah, it's the right cam. It is what it is. It's actually a big camshaft for this application, but you know, that's what he wants. So it's going to be radical. So yeah, that's basically cam degrading in a nutshell. There's a couple other things you can do like lobe separation and all that stuff, but I have other videos doing that. So I'm satisfied with that. Okay, so that is cam degrading in a nutshell. Now I know that the numbers were off a little bit, but you know, there's some guys that get all twisted out of shape if they're off by a few degrees from what the cam card says. Man, I'm telling you, don't worry about it. We're talking about a stroke in the engine that's this long, right? A couple of degrees one way or the other. The degrees do matter when it comes to intake lobe centerline, because that's timing. A couple of degrees advanced or retarded is going to change the motor. But when it comes to duration, if you're off by a couple of degrees when you degree it, don't worry about it. I mean, a couple of degrees of duration, I mean, we're literally talking about the thickness of a human hair, right? When you have a valve that opens that much, ½ inch or whatever, 600, whatever it is, well, we can do the math. We have basically 350 thousandths of lobe lift, so we'll say 0.350, 350 thousandths. To get you actual valve lift, you have to multiply that by the rocker ratio. I believe it's 1.5. We'll just say it is. I'd have to walk over and look at the rockers, but I think they're 1.5. So times 1.5, that's our rocker ratio, 525 lift, right? So that's a ½ an inch of lift, more than a ½ inch. A couple of degrees with a valve moving that far on duration, opening and closing, it is literally the thickness of a human hair. That's how far it's moving. So I'm telling you, don't worry about that if you're off a couple of degrees. So I'm gonna make this one video. I've got a ton more to do on this engine. One thing I don't have is I don't have the timing chain cover. I ordered a new one. Man, I'll tell you, one thing I've noticed with this whole COVID thing that's going on, and I'm sure you guys have experienced some difficulties, I am having a really hard time getting parts. I mean, if you go to Summit's website or my supplier EPW, they've just flat out tell you shipping times have tripled, right? Because of COVID. They don't have enough staff. They're not able to manufacture stuff quick enough. And then add to the fact that I'm building an engine. It's not a small block Chevy, it's a Pontiac. And so the parts are even much harder to get. The camshaft, they had to make it for us. They literally had to manufacture it because they didn't have any in stock. So I'm waiting for the front cover. I don't want to use the old one. It's an aluminum cover that goes on the front. It has coolant going through it. The old one was we're going to go ahead and put a brand new front cover on it. The short box basically done. All I got to do is put the front cover on the pan and button it up. I did order the valves, so the valves are coming. You saw in the last video we worked on the heads. Basically all I'm waiting on the heads is the valves, so I can finish up that valve job, because I've got the guides in, I've got them both milled, and we'll go ahead. Now, one of the things that we're going to do in the videos coming up is we're going to CC the heads and check the combustion chamber. We're going to calculate our compression ratio on this engine. I think it's going to come out really close to what we're shooting for. So we are a little bit limited because it's a 350, but we want to make this 350 as good as it can be, right? We want, you know, if you build a Pontiac 350 right, even with a smaller bore, they have a pretty good punch. They can be a pretty potent power plant, and that's what we're planning on having here. So I appreciate you watching. I got a bunch more to do to this off camera today. The car is being restored completely. I don't know if you did the frame off or whatever, but they've done a lot of work to the car. It's going to be a really nice deal. And the customer is trying to coordinate. He's getting a little bit antsy because I've spent a long time on this, but honestly, I haven't been dragging my feet on this build. I just haven't been able to get parts for it. I'm doing the best I can. So I'm hoping that this next week I'm going to get the front cover. That way I can get the pan and the front cover on, and I'll shoot some video on that. And then basically get the valves, get the heads done, put this baby together. So I appreciate you watching. I will talk to you very soon, I promise. Stay tuned for the next video I do is probably going to be the last one. We're going to button this thing up. So I will see you then. Thanks for watching.